Okay, here we go. Unit 5, or I'm sorry, Unit 1, Day 5. Now, by the way, tomorrow's lesson, we'll probably spend a couple days on it, will be based off of trying to get used to using our graphing calculators. And I'll even throw out a little calculus and let our calculators do it, so you guys won't have to understand it too hard, but just know where to do it on your calculator, and probably put a couple questions on your next test with that. But anyways, you want to get a graphing calculator, one that you know how to use, that you're comfortable with. I'm going to be mainly showing TI 84s, 83s, I think, as far as what I demonstrate. And other TIs will probably be very similar, Texas Instruments. Otherwise, other brands are fine. I've had students use all different kinds of brands. If you want to make sure they're allowed on the AP test, go to the College Board's website or just Google advanced placement AP Calculus approved calculators, and they'll have a page that probably pops up from the College Board that lists all the calculators that are allowed. And there's a lot. You mainly can't have ones that are like Wi-Fi enabled or can communicate and stuff like that. That's not going to be allowed during the calculus exam. You could use this for your homework if you want. In fact, you can get apps on your phones that mimic Texas Instruments or other calculators. You can use that for homework if you want, but on my tests and AP tests, you won't be allowed to use those. Okay, so first, let's do a warm-up. You should try all these problems. Number 3 is kind of a new one we haven't done. It's an absolute value inequality, which I want to talk about today, but this is something you should have learned how to do back in even Algebra 1. So I want you to try that one whatever way you would have learned to do it. And I might show you some new tricks today, or maybe you'll have seen it that way before. So try these problems, including number 3, and just see what you can do, okay? So go ahead and pause the video. Try those 3 problems. Okay, now you've tried these 3 problems. So here are the solutions to those. So you can check those. You can pause the video, and so you can see those. I'm going to get rid of them right now. And I'm going to go over these, okay? So you can see those answers are, number 3 might be interesting how you did that. That's the answer. Interval notation, of course. Okay, so let's try these warm-up problems. See if you're getting good at this. So this is rational inequality. Now, the thing about number 1 that's nice is it's all on one side compared to 0. It's all in one fraction. That's nice. So let's try and factor it. Now, the top is factorable. It's irrational. Its roots are irrational. So it's going to be x plus the square root of 8, x minus the square root of 8, right? I mean, you could do that. You could set it equal to 0 and solve it. X squared equals 8 squared to both sides, plus or minus. X equals plus or minus. Now, we could simplify this to 2 root 2, which I think I'm going to probably ask you to do. A little nicer, simplified. You could do quadratic formula, by the way. So I factored it, thought of it as a difference of squares, even though 8 isn't a perfect square. I could still pull it off. You could solve it. You could use quadratic formula, which would be a lot of work compared to these ways. Bottom GCF, always look for the GCF first. Keep that inequality symbol there. Okay, so we have x equals negative 2 root 2, x equals positive 2 root 2. We have x equals 0 and x equals 2. No double, even multiple roots, so no little stars or bounces off the graph or whatever. Now, negative 2 root 2 is clearly over here. It's a solid dot because it comes from the top. And then 0 should be next. That's an open dot. And then 2 root, now square root of 8 is it's between square root of 4 and square root of 9, right? So it's it's really close to 9 though. So it's probably like 2.8 or something. Now, I'm only doing that to make sure I put it in the right spot on my number line. I don't want that in the answer. And you should be able to pull these off without a calculator. You're going to have to do these on your next test without a calculator. So 2 is definitely next. And then 2 root 2 is next. That's the only reason I did that, was to make sure I got it right here. Well, one of the only reasons. Now, when you go to test, if you want to test far right, then you need to be like, oh, well, x equals 3 would be a good value to test. That'd be 9 minus 8 is 1. Positive, positive. Everything's positive. It's true. False. True. False. True. So we darken in those. Now, final answer is negative infinity to negative 2 root 2 bracket union 0 to 2 parentheses union bracket 2 root 2 to positive infinity. There you go. Next one, we got to move everything one side. They didn't do that for us, so I'm going to subtract that whole thing from both sides to get a 0 over there. Then I'm going to give these guys least common denominator. So this is going to get a 4 on top and bottom. This is going to get x plus 6 on the top and bottom. And I'm going to get x squared plus 6x minus 4x minus 4. You got to distribute this negative over. Now the bottoms leave those factored. Keep that less than or equal to 0. Now let's combine like terms. And let's try and factor the top. So x and x, it's got to be pair numbers that multiply together to get negative 4, but add together to get 2. So what is that? It's got to be positive and negative, right? So small number should be a negative 1. Negative 1 times positive 4. No, it gives you 3. 2 and 2? No, it gives you 0. So we can't factor this. So we're going to have to do quadratic formula, which we've done. So it's going to be x equals negative b plus or minus the square root of b squared minus 4ac. You guys really better know this quadratic formula. This is like one of the few formulas you've probably memorized over the last 4 years of math that you should really know. All over 2a. Okay, you got to be real careful though with it. It's easy to make mistakes. So that's why I'm plugging everything in parentheses first. Plus 16. It's not going to be imaginary. We're getting answers from it. 20. Now, you can take 2 out, 2 out. So we can take a square root of 2 times 2 out, which is a 4. So we get negative 2 plus or minus 2. Square root of 4 is 2. Every pair gives you a single number on the outside. 5 still left on the inside. It's going to be negative 2 plus or minus, no, negative 1. Now, distribute this to both these. They both got to be divided by that. So we're getting negative 1 plus root 5, which is about something, and negative 1 minus root 5, which is about something. Now, I'm going to estimate these without a calculator. Square root of 5 is between square root of 4 and 9, so it's between 2 and 3. It's closer to 4, so I'm going to say like 2.2. And so it's going to be like 1.2 after you subtract 1 from it. This is going to be like negative 3.2. At least I can get them in the right spot. Now, I'm going to put my number line over here. Okay, x equals negative 6 comes from the bottom. That's clearly the furthest to the left. It's open dot. These are going to be solid dots. So the next one would be negative 1 minus root 5. I want perfect, exact answers. These decimals, don't write them in your work. That was just to make sure you get it right. And the next one is negative 1 plus root 5. All right? And we test the value. X equals. Now, you could use this to be like, well, if I plug 2 in, then that should be safe enough at far right. 4 plus 4 is 8 minus 4 is, that's positive, which is false. No even multiple roots, false, true, false, true. So your final answer is negative infinity to negative 6. Parentheses, always parentheses on infinity. Union, bracket, negative 1 minus root 5, comma, negative 1 plus root 5, bracket. Exact answers. I don't want any of those decimals. And you should be able to do these without a calculator. All right, so that's all the review stuff. So now this one, let's do this the way I think you might have learned how to do it back. Well, I don't know. This is the way I used to teach in like Algebra 1, Algebra 2. First of all, this problem is going to be a ton of work the way you used to do it. One thing we can do is we can break this up, and that makes it a little simpler, into these two. There's two separate conditions. There's this one, and then there's this one. The word, though, that has to be between them is and. Okay, that's key. They have to both be true at the same time. Now, this one, I'm going to rewrite. I'm going to flip it around. And you're allowed to flip inequalities around as long as you flip that symbol around too. Okay. Now, the way we would solve absolute value single inequalities like this is the way I would teach them. You would say x minus 1 is greater than 2, and then you say x minus 1 is less than negative 2. Now over here you do x minus 1 is less than or equal to 5, and then you do x minus 1 is greater than or equal to negative 5. So you would drop the absolute values for the first scenario, and then the second one you would change the sign of the number on the right and flip the inequality. Okay. Now the word that goes in between them makes a difference, because this is, when you do absolute values, you got to think distance on a number line. I'm going to stress that a lot. Distance on a number line. This is further than 2 from 0 on a number line. So you're going to get, here's 0, and here's 2 away in both directions. I'm going to take advantage of this to teach you guys a shortcut later. It's got to be more than 2 away. More than 2 away. And distance doesn't care if it's in the negative direction or not. So you got these answers or these answers. We don't want anything in between. We don't want them to overlap. So the word is or, okay? Whereas this one over here, this is distance less than 5, right? So that's and, because you got to be from 0, here's 5 away, and you want to be less than 5. So you want to be closer than 5, but you want to be closer than 5 from both sides at the same time. So that's an and thing. So you got this, and you got this, and you have an and in the middle of all of it. Now we're getting closer to getting our answer. Now after this is a bunch of little tedious work. Get this x by itself, right? Add 1, get that x by itself. Okay, now let's go ahead and finish solving this. The way I usually do this is I do a number line, just one number line. Well, I mean, that's about as far as we can go. So let's see, 3. This is what it looks like as a picture, which might be helpful later. Okay. This one, add 1, add 1. Add 1, add 1. But the word is and. So what it's going to look like, I'm going to put it right underneath this, okay? So it's going to be x is less than 6 or equal to. So solid dot at 6 less than to the left, and then greater than or equal to negative 5. So solid dot negative 5, which should be the left of negative 1. But it's and, so even though this keeps going and this keeps going, it's only where they overlap because of the and. Okay? So this is what the left-hand side eventually boils down to, and this is what the right-hand side eventually boils down to. And then we have an and between them, which means that both of them have to be true at the same time, which is going to be where they overlap. So it's going to be negative 5 to negative 1 union 3 to 6 bracket. That's your final answer. Oh, shoot. Did I make a mistake? Oh, yeah. This is supposed to be negative 4 over here. So this is supposed to be a negative 4, and that's a negative 4. So close. The big details right. Now, that's how you could do it. I'm going to show you a really fast way to do this problem. Get the same answer, okay? But, I mean, that's the way you would have done it, I think, mostly. That's the way I taught my Algebra 1, Algebra 2 kids years ago. But I got a way better trick for you. It's not even calculus. It's just a different way to trick. Okay, so I'm going to teach you that trick right now. So this is key, okay? And this works on easier problems than that too. It's going to be super speedy. So absolute value is distance, that the distance from 0 to A. That's what it means. Absolute values is distance on a number line, okay? Now, one way you can deal with absolute values are always going to be a pain in our butt this year. And we're going to deal with them in a lot of different situations. And they've been a pain in your butt since Algebra 1. And usually what happens is there's two different situations that you have to deal with, okay? And with inequalities, it gets a lot messier, as you can see from that problem up there. One way of dealing with absolute values is to rewrite them as piecewise functions, okay? And this is something you probably would have done a bit of in pre-calc. Piecewise functions are just functions that are written with different parts of their graph are different curves and have different equations. And absolute value functions, if you graph them, look like this. They look like two lines. There's not really a way to write this without absolute values, right? This is the absolute value of x. But one way you could do it without the absolute values is to say, well, it's just going to equal a when a is positive or equal to 0. And if a is negative, then it's going to force it to become positive by applying another negative to it. So when a is negative, it's like the negative of the negative makes it positive. So it's another way of dealing with it. There's two scenarios. Now, just to try and make this as simple as possible, this is a story from Mr. Statham. He had an Uncle Roger who was a carpenter. I have a dad. His name's Glenn. I call him Dad. I don't call him Dad Glenn. And he was a building contractor, so he was always measuring things, measuring tapes, all these tools. And his tools would get kind of cruddy and banged up and broken, but they would still work. And measuring tapes, what happens sometimes is the end gets all ripped off and it gets all jagged, which is semi-dangerous. And you can't really measure from the beginning of the measuring tape anymore. So this is what Uncle Roger would do. He'd be like, well, let's just start at the next nicest inch. Okay, I'll start at inch 1 and go to inch 13. And then you could find the length of that, right? Would it be 13? No. How would you do it? You'd say, well, let's subtract one of these from the other, either one, by the way, and force it to be positive. And you get your length. Okay. Now this idea is kind of the idea that we're using with absolute values. We're saying, well, what's the distance between two different locations on a number line? And it doesn't have to be 0 anymore. And we take the absolute value of the difference of them. And by taking the absolute value, it forces it to come out positive every time, which is what distance should always be. It should always be positive. Okay? Now, if we go to this problem right here, here's an absolute value inequality, a simpler one than on the warm-up, but still something that we could find a shortcut to. Now, the way you used to do it, okay, here's the way you used to do it. The way you used to do it is you do it like this. At least is the way I taught my students. You would just drop them, and then you flip the symbol and change the sign. And then the word in between was critical. If it was distances smaller than 5 from 0, then you wanted to be closer than 5 away from both sides. And you wanted it to be true for both of them, because just because it's to the right -5, but it's at 100, that's not less than 5 away from 0. So you had to do the word and. Okay? And that makes a big difference. Because if it's or, that's a totally different answer. Okay, and so then you would solve each one on its own. So this is the old school way of doing it. I'm going to show you a new trick. And then, to me, I would be like, okay, well, open dot 8, error to the left, open dot -2, error to the right, and they usually overlap each other, and you need them to overlap each other, and the final answer would be -2 to 8. Okay? Now, that doesn't seem too bad, but I'm going to make it even better. Okay? We're going to use this ruler postulate to help us. Okay? So we want to think of this a little deeper and say, okay, we want, and usually you're not going to write this down, but we want points 5 units away or less, right? From 0. Well, think about what a -3 does to a function. What would that do? What would the graph of this look like? You guys know what happens when you subtract something from x inside of a function? We're going to study this a lot. You guys should have done this a lot in your previous classes. It shifts it to the right 3 units. So the graph looks like this now. The original graph looked like that, right? This is y equals absolute value of x. You put a -3 on the inside, it moves it to the right 3 units. That's the new kind of center of this, okay? Usually the center is at 0. So now we want points 5 units away or less from 3, not 0 anymore. If it just had absolute value x, it'd be 0. So let's just kind of visualize this and say, well, 3 is the new middle, and we want to be 5 away from the middle in either direction. Can it be equal to 5 units? No. So these are open dots. So I'm going to add 5 to this. That's 8. Take 5 away from this. We're at -2. And these are all your answers. -2 to 8. Done. Same answer we got right there. Okay? This is super fast. And it's going to make that warm-up problem way easier. So what you'd be like, all right, the center's at -2, right? That's the new center. And we want to be 4 away on both sides. Open dot. But this time we want distances bigger than 4. And this is going to be at 2, and this is going to be at -6. There's your answer. Negative infinity, -6. 2 to positive infinity. Done. That's the fast way. That's what you want to do. Okay? So in the back, I got couple examples for you to try. And then we got some special cases to talk about that we might do something a little different. So you guys try this one. First one, top one. Pause the video. Okay? Pause the video. Try it. So I'm going directly to number line. Center's at 2. We're looking at 5 away. Open dots. 5 added to 2 is 7. 5 taken away from 2 is -3. We want distances less than, right? So in between. There you go. Done. All right. Now, I want to show you something on a graphing calculator because we're going to start using graphing calculators more. You don't need this for tonight's homework, but just to start to get you thinking about it. We're going to get some really weird functions, okay? And we could use our calculators to help us. So one way we could do this problem, just to start getting you thinking, I mean, this isn't going to be better than this, but just to get you started thinking, we could graph this function and graph this function in our graphing calculator. So we're going to go to the Y menu and type these in. Now your calculator actually has an absolute value function. It's under, on mine, it's under the math button. And then you go over to num, and ABS is absolute. So if you have a calculator on mine, it's probably in there. And then you put x minus 2. And the next one is going to be y equals 5, which is a horizontal line. Now, I already know what this is going to look like. I'm just trying to show you how a calculator could do it. This is simple enough to do without it. You guys should know that this graph is going to look like this. This is absolute value graph, and it's just shifted over to the right 2 units, right? So that's the new vertex. And then it has a slope of 1 on both sides. And it just goes like that, right? You guys should be able to graph this without a graphing calculator, but I'm going to show you how a graphing calculator will do it quicker. And then this is a horizontal line, 3, 4, 5, right? Y equals 5. This is y equals absolute value of x minus 2. And what we're asking is, where is the absolute value graph below the horizontal line graph? Where is the v below that? Well, that's from here to here, below and not equal to. Well, guess what the answer is going to be? -3 to 7. -3 to 7. Same answer we got above. But here, let me show you on your calculator. So I'm going to put ABS x minus 2, and I'm giving you some little notes about where to find it, and then 5. And then I'm going to go to window, and I could do zoom standard, which is zoom 6, which is a 10 by 10, -10 and -10, -10, -10 both directions. So there's the graph, right? And then we can use our calculator to find these intersections because that's what we're interested in. We want to know, where is this below that? Well, where does it cross it? Second calc, number 5, intersect. And then you got to tell what curves you want intersections between, because it can only do the intersection between 2 curves at a time. And I know we only have 2 curves, but sometimes we get 5. So it tells you which one you're on. You hit enter, enter, and then you got to give it a guess, because otherwise it's going to give you the closest one. So you want to get close to it. So it tells you that, -3, 5. And then we do it again. Second calculate, number 5, intersect, first curve, second curve. Now, instead of hitting the cursor over all day, you might be like, well, 1, 2, 3, 4, 5, 6. That looks like it's around 6. That's faster. And it tells you 7, 5. Now, it's the x coordinates that we want, right? And so we can find the answer that way, right? Now, because we're asking, where is the v graph below the horizontal line? So that's one way of doing it. Now, on this problem, clearly not the easiest way to do it. I'm just giving you some ideas of some crazier problems I'm going to give you. Now, for some special cases, what if you have 2 absolute values in your inequality? We haven't seen any like that. How do we do that? And by the way, actually, let's go back to the warm-up problem. Let me show you how to do the warm-up problem way faster. So warm-up problem, because this will be good. The warm-up problem has 2 conditions. What we do, though, is we say the middle is at 1. We want to go 2 away in both directions. These are going to be open dots, right? We all want to go 5 away from the middle. 5 away. Now, this is going to be at 3, and this is going to be at -1, right? If you go 2 away from 1. And we want to go 5 away. These are going to be solid dots. right? Now, if we go 5 away from 1, that's at 6. 5 away from 1 here is going to be at -4. We want the things that are more than 2 away, but less than 5 away at the same time. It's going to be those little chunks, -4 to -1, union, 3 to 6, bracket on the 6. That's your answer. That's the same answer we got up here, but it was so much harder and so much easier to make mistakes on them there. Do it this way. Ruler postulate all the way. All right. But we're going to have some problems that's not going to necessarily be the best way to do it in these special cases. What if you have two different absolute value functions? To split this up into all the cases, there'd be 4 different cases and lots of ands and ors and all kinds of stuff. So here's the trick. What if we squared both sides? All right. Could you get rid of the absolute? First of all, could you square both sides and would it still be true? Is if 3 is less than 4 and you square both sides, is it still true? 9 is less than 16? Yeah. So if you square both sides and there's no negatives involved, then that should still be true. Now, these absolute values means that they're for sure going to come out positive. And when you square, that's going to force it to be positive. If you square an absolute value, you don't need the absolute values anymore because it's going to be positive no matter what, right? So this should still be true. Yes. Okay? That's the trick to problems like this. They have two absolute values. We're going to square both sides because what that does is, it gets a little messy at first. 4x squared minus 4x plus 1. You got to FOIL it. And then over here you get x squared plus 6x plus 9. Now, you might be like, oh, that's bad. But you got rid of the absolute values. That makes it so much easier. Now, this problem is just like problems we've been doing for days. This is a polynomial inequality. Move everything to one side. Set to 0. 3x squared minus 10x minus 8 less than 0. Right? Factor it. Can we factor this? 3x and x for sure. And then we need a positive and negative. It's got to multiply to get 8, but add together to get -10 in the middle with the 3 involved. So if I do 8 here and 1 here, no. 2 and 4. 2 here, 4 here. Oh, I think that's it. 4 here gives you the 12. 2 here gives you the 2. 12 minus 2. You want the 12 to be negative and the 2 to be positive. That gives you that. So x equals -2/3. X equals 4. Line check. Open dot. Test the number, far right, it's my favorite. Positive, false, true, false. Watch out for those bounces. None here. That's your answer. This is way faster than anything else, okay? So I'm not doing ruler postulate because there's more than one absolute value, okay? Square both sides if you have two absolute values, okay? Now, here's another kind of problem I gotta show you. Now this idea could apply to a single absolute value also, okay? The big deal here is you might think, oh, well, the middle is going to be at 2, right? First of all, that is the middle because it's going to be whatever makes this 0, right? But then you might be like, all right, I'm going to go 3 away on both sides, and then I'm going to go 9 away on both sides. Okay, this is also an issue for a single one, okay? What you got to do first is you got to get this to a 1x. Okay, so you got to divide everything by 3. Now, you're not getting rid of the absolute values. You're just changing the coefficient of x on the inside to a 3. Now, you got to divide everything. Okay? Now, you can easily see the center is 2. And now you're going to go away 1 in each direction and 3 in each direction. Okay? So the ones are going to be open dots because there's no bar under here. So that's going to be 3 and 1. And the 3s are going to be solid dots. And 3 away from 2 is 5 and -1. And we want everything that's more than 1 away, but less than 3 away. So it's going to be -1 to 1, 3 to 5. Okay? One other special case, real quick. One other special case. What if you have two absolute values, but it's an equation? Okay? Now, to do this, you would have to do a bunch of cases, you would say, well, 2x minus 1 equals the inside of that, positive this equals the positive that, the negative of this equals the positive of that, the positive of this equals the negative of that, the negative of this equals the negative of that. I mean, there's 4 cases, okay? But here's the deal. You don't have to do all 4 cases. You can just do, because a bunch of these end up becoming the same thing. This is the same as this, so we're not going to do that. These are the same as this. We're not going to do that. So the shortcut is do both of them equal to each other without absolute values, and then do one of them equal to the negative of the other. It doesn't matter which one you do. And then you're going to solve both of these separately. Now, there's no inequalities. There's no interval notation. These are just going to be separate answers. So like here, you would add 1, you subtract x from both sides, you get x equals 4. So that's one of your answers. And here you would add x to both sides, add 1 to both sides, and they should give you different answers. 3x equals -2, so x equals -2/3. So your answers are -2/3 and 4. No parentheses, none of that, no line checks. Okay? All right, that's it. Try the assignment. It's a separate worksheet. Check your answers. The answers put online ahead of time. Check them as you go. You don't want to find out at the end of the assignment you're doing them all really bad, right? You want to figure out what's going on quickly. Check them as you go. Try and figure out what's going on. Okay? All right. We'll go over questions on tomorrow's video.